Hello, this is video 76. I'm going to go over a problem that is often called Archimedes' crown. There's a story that Archimedes was trying to figure out if the crown was made of gold, and apparently he was in his bathtub and he figured out how to do it, and he jumped out into the street naked and screamed "Eureka!" That's how the story goes. So let's take a look. First, we have this question to help us get started on this problem. This question here says that the crown is weighed in water. Which equation correctly describes the forces acting on the crown when it is immersed in water? We've already mentioned that when things are submerged, they appear to weigh less. And this is because of the buoyant force that's acting on it. So when you have your crown in the water, this is the crown here, it's in the water, then we know that we have a buoyant force on it. We know that there's a scale rating, which I like to call T, because the scale rating corresponds to that tension in that string. And then there's also the weight of the crown. So when it's just being weighed there, it's in equilibrium. All the forces must balance. So that means that we have the sum of the forces equal to 0, and we have B plus T minus W equals 0. So which choice is this? This is choice B, where I've used Fg instead of W for the weight of the crown. So this is just a your turn question to get us started on the actual problem. So in the problem, what we have is that the crown is weighed in air and it has a certain weight. And then it's weighed in water and it appears to weigh less, 6.84. And we're also given the density of gold. So if we have to figure out if the crown is made of gold, then we have to find out what's the density of this object and see how it compares to the actual density of gold. We already have some free body diagrams drawn for us. Let's take a look at the first one here. So the crown is in equilibrium, so we know that the T balances out the weight. So all this tells us is that this T, which is 7.84, is really the weight of the crown in air. That's what it says. So Fg, or I like to call it W, is equal to 7.84. That's the real weight of the crown. So that's the same number that we have down here. But T2 is going to be the weight in the water, right? T2 is a scale rating. It appears to weigh less. So T2 is equal to 6.84 newtons. But we just saw in the previous problem that T, or in this case T2, plus B minus Fg equals 0. We know T2 and Fg, we can figure out B. B is equal to Fg, or W, minus T2. So 7.84 minus 6.84, that means the buoyant force on this object is 1 Newton. This makes sense. If the water pushed up with 1 Newton of force on the crown, then the crown appears to weigh 1 Newton less than it really does. How can we use this to find the density of the crown? We're going to use Archimedes' principle. Archimedes' principle tells us that the buoyant force is equal to the weight of the fluid displaced, the density of the liquid, the volume of the fluid displaced, times g. We saw in the previous video that when an object is completely submerged, no part of it is sticking out of your liquid, then the amount of liquid that is pushed out of the way by the object is equal to the volume of the object. So volume of fluid displaced equals the volume of the object when it's completely submerged. So we can replace this equation by density of the fluid, the volume of the object, times g. Now we're trying to figure out what the density of the object is, not what the volume is. Well, we have an equation that relates the density to the volume and the mass. Density is mass per volume. So that means that volume equals mass over density. This means that the volume of the object is equal to the mass of the object divided by the density of the object. And we often use this relation to go back and forth between volume, mass, and density. Let's see what we have now when we replace the volume of the object by its mass divided by its density. And this was equal to the buoyant force. And the buoyant force, we said, was equal to 1 Newton. What are we trying to solve for in this problem? We're trying to solve for the density of the object. I'll keep this at B for just one more second there. We're trying to solve for the density of the object. Multiply that by both sides, and then divide both sides by B. When we solve for the density of the object, we're going to get density of the fluid, mass of the object, times G, divided by B. And now we can plug our numbers in, and we can find the density of the object. The density of the fluid displaced, which is the density of this liquid here, which is water, is 1,000 kilograms per meter cubed. It's the density of water. The mass of the object, we don't know the mass of the object, but look, it's multiplied by G. mg is the weight of the object. The weight of the object is 7.84 newtons. Remember, Fg is equal to mg. So no point dividing 7.84 by g to find the mass, because this 7.84 is the whole mg. It's this whole thing. We can just put in 7.84 for that, and then divide by the buoyant force, which was 1. And we get 7,800 kilograms per meter cubed. We were given that the density, if we go back here, the density of gold is 19,300. So this density is nowhere close. So that means that this crown was not made of gold.